Second example, we want to find the radius of convergence for this series, this power series. Alright, this is a power series centered at x equals 0. Notice here that this term right here, this x to the 2n plus 1, is really x minus 0 to the 2n plus 1. And the rest of this is our coefficient. Alright, so for any fixed value of x, such that x is not equal to 0, we're going to try to do this ratio test. So we have a sub n plus 1 over a sub n, the absolute value of. So we fill these out. We have n plus 1. This becomes 2n plus 3, because when we go 2 times n plus 1, that ends up giving us a 2n plus 3. We have 2n plus 3 factorial here, and so on. So we can see that here the 2n plus 3, the 2n plus 2 remains. Everything else gets canceled out when we multiply by the reciprocal here. The 2n plus 3 and the 2n plus 1 cancel out everything but an x squared. Right, and here these negative 1s, we actually are left with a negative 1 because we have this absolute value symbol. The negative 1 doesn't come into play, so we don't have to put it here. So when we look at this, we see there's an x squared in the numerator, but we have a 2n plus 3, 2n plus 2 down here. X is a fixed value, so as n approaches infinity, this fraction is going to approach 0. Right. So what that means is that for any given value of x, this series converges. So it converges for all values of x, all finite values of x. All right. So the radius of convergence is infinity. We can go as far away from x equals 0 as we wish, so long as we have an infinite number of terms. So we have lots and lots and lots of terms in this power series. We can move as far away from 0 as we want, and we're still get a convergent series. The next example, we want to find the radius of convergence of this 3 times x minus 2 to the n. All right. So this is a power series centered at x equals 2. So what we're trying to figure out is how far away from 2 can we go and still have a convergent series. So we apply the ratio test. And you'll notice here that the ratio test looks like this. We have x minus 2 to the n plus 1, x minus 2 to the n, both with coefficients of 3. The 3's cancel out. X minus 2's, all those powers of x minus 2 cancel out except one of them. So we're left with the limit as n approaches infinity of x minus 2. Well, there's no n here. So as n approaches infinity of x minus 2, we're just left with x minus 2. Right? We need to ensure convergence, we need to make sure that that is less than 1. Right? So we have to make sure that the radius of convergence is this absolute value of x minus 2 is less than 1. So we get a radius of convergence of 1. So we know that as long as we're within 1 of 2, then we're okay. But we don't know what happens at the endpoints. So we still have to test the endpoint convergence. All right? The radius of convergence is 1. So if we're less than 1 unit away from 2, then we're okay. But we need to make sure, we need to test what happens at x equals 1 and x equals 3 still. Right? We haven't done that yet.